All right. Arithmetic sequences sounds like a really funky thing, but it's really not that bad. All this means, when it says something's an arithmetic sequence, just means, what do I add each time? So what I'm doing is I'm looking for patterns. And if I can find the same pattern, if I keep adding the same number each time, then it's called an arithmetic sequence. If the number changes, then it's not. So here's how this works. When we start looking at these, so like for instance in number 1, what do I add to 4 to get up to 7? 3, okay. So here but the question then becomes, but what about when I go from 7 to 9? It is. As soon as you see two different numbers. Yeah, but again, once I see that it's not the exact same pattern all the way through, it's not an arithmetic sequence, and I'm done. Okay. So the only time that I have to keep going and find to see what the other terms are is if it's the same number every time. So for instance,
so as soon as you stop doing the same number, we can just stop doing it.
Then you can stop doing it, it's no. Okay. Now, this one's going to seem odd because you're going to be, well, you're not adding, you're subtracting, but it's the same idea. How do I get from 15 to 13? A minus 2, okay. What about 13 to 11? Oh, it's the pattern's sticking. Hang on, let's see, we may have one this time.
I don't understand this.
Okay. So if that pattern continues for all of them, because I keep minusing 2 each time, this is going to be a sequence.
Wait, yes or no?
And then, well, explain. You're just going to say I'm adding negative 2. It doesn't have to be like a paragraph explanation like we're in English. Just a quick, simple, I just keep adding negative 2 each time. So if I wanted to find, 5 more terms, I could because the pattern's the same. So like I said, on some of these, that'll work. Some of them it won't. So like on number 3, what am I adding each time?
3.
Yeah, I keep adding 3 each time. And it works for all of them. It's not like it only works for one of them. So that'd be a yes. And I'd add 3. Uh-huh. Yep, we'll be coming to that one.
No, I didn't know because I had other papers on it.
So what about number 4?
That's no.
That's no, because as I'm going here, I add 1, but then to get from negative 5 to negative 3, I add 2. As soon as they change at all, it's no, and I'm done. But again, you've noticed here it can be a positive number I add, it can be a negative number that I add, but it's got to be consistent. Now some of these get a little more interesting. Let's see. What about number 5?
That's yeah.
That's going to be yeah.
Added 2, I think.
Nicely done. I'm adding 2 as I go from number to number. So that would be a yes. Because I'm adding 2. Good. Let's do one more of these. Let's do 6.
That's I think it's added negative 3.
Nicely done.
That is easy.
Okay, each time we're adding negative 3, so that's a yes. So again, it may seem like subtract, but we're just adding a negative. Okay, so this next group, they're all sequences. I'm letting you know that in advance. We're going to find the next 3 terms. Now, we don't have to do number 10. It's just like number 9. That'd be kind of silly. What am I adding each time on number 9? Okay, so each time if I'm adding 4, and I get to 15, what are the next?
19, 23, and
Nicely done. Uh-oh. All right, what about the next one? What about 11?
It's minus 2.
Okay, on 11, we're going to add a negative 2, or we're going to minus 2 each time.
Yeah, minus 2. add minus 2.
Or you can just look at it as minus 2, that's okay.
I don't,
Because when you're doing an arithmetic sequence, technically the word they keep using is add every time, even though we can subtract as well.
it's 14 12 times.
Yeah, we just keep taking 2 away each
I
time.
don't get that though.
The whole add negative 2 thing.
Yeah.
Because if you think about it,
Why would you add negative 2 when it's a minus?
that's the same thing.
It's like the same thing.
Yeah.
I
It's
don't get that.
okay.
It's like subtract.
Here, let me pop this up and let's see if this kind of helps a little bit. If we take a peek, right now we're discussing, shh,
My bad,
You need to subtract.
you could. So some of you are saying, well, okay, so let's say we're doing 16. You're like, well, I'm just minusing 2. And I know that because, well, that's where my numbers are coming from. You know, I'm doing this. What I'm saying is, if I said, okay, instead, I was going to add negative 2, the same thing's happening each time. So if you want to look at it
Oh, okay.
as though you're minusing 2 instead, that's okay. You'll get the same answer. Okay? So let's see. Let's find another one that might play that way a little bit. Let's look at 12 and 14, and then I got one more part we want to look at on here, and then we'll be good. What's my pattern on 12? What am I doing each time? Minusing 2. We're adding negative 2, okay? And again, you can look at it either way. So if I'm minusing 2 each time, now am I minusing 2 each time? Let's look at this again. If I owe somebody $13 and I subtract 2, I think I'd owe them 15.
Yeah. So I think it's 4.
Maybe add positive 2?
Yeah.
Let's test this
Yeah,
out.
it's positive 2.
Okay. Because if I'm not sure, I can always say, okay, let's see, negative 13 plus 2. Let's see. Okay, that got me to negative 11. That got me to the next one. So once I'm sure, what are my next 3 going to be after
Negative
negative?
11, negative 5, and negative 3.
Okay, negative 5, negative 3. I didn't hear the last one.
No, that's
Negative
fine.
1. Okay.
I don't know where I got negative 11.
Hey. Last one here, 14.
It's 12. It's minus 5.
Okay. Minus 5 or add negative 5. I don't care which way you look at it. What?
Supposed to be a minus 5.
Yeah, you can either minus 5 or you can add negative 5. What would those next 3 numbers be?
It's negative 8, negative 13, and negative 18.
Okay. I keep taking that 5 away or adding negative 5. Now, I will say for the next part, we're not going to use the big fancy formula that's there. What I want you to do when we get down here, I want you to find the pattern. I want you to tell me what we're adding each time. So we're going to do 15, 16, and 19, and then we are going to be done noting here. So let's see. 15. What am I adding each time?
Adding.
Or, okay, what am I subtracting in this case? Okay, so remember, subtracting 9 is the same thing as adding negative 9, whichever way you want to look at it. Okay, so if that was the case, let's just find a couple this time.
It's negative 20, negative 29, and negative 30.
All right, that's going even above and beyond there.
I hate
I don't know if I'm jelly.
You don't understand it?
Why don't you tutor her?
The easy ones.
They're hard to-
Well, now let's see. Well, now 16, this could be interesting. This is the first time we've had a decimal. Oh. Now, if you're not sure on the decimals, here's a trick.
That's really 2.5 though.
It is. Nicely done.
Yeah, I know.
Here's how you can do that if you're not sure. You can take any 2 terms in here. So let's even say we did the middle ones. You can always take 2 of them and just subtract them from each other And that'll always tell you what the difference is going to be. Because you notice no matter which pair I choose, I keep getting 2.5 each time.
Wait, you add 2.5?
Yep, we're going to add 2.5 each time.
So that's 12.5, 15, 17.5.
Yes, yes it would be. And I would just keep adding those as I went along. Good. What about that last one?
It's minus 4.
Okay, so again, it's either minus 4 or I can add negative 4. Doesn't matter. Next two.
10 and 6. 14, 10, 15.
Okay. I'm like, she got ahead of me one. Okay? So here's what I want you to do as far as the homework sheet goes with this one. Let me move this to the side. We're going to trim things up a little bit. Nope, we're going to trim things up.
I do 16.
On this sheet, we're just doing 1 through 16. Okay. So up top, we have to say if it's arithmetic or not. In other words, can I add the same number all the way through? The second part says find the common difference. That's a fancy way of saying what's the pattern? You know, what am I adding each time or what am I subtracting? Okay, because since those would basically be the same thing, that's what we'd be looking at on there. Now, the one thing I'm going to change the directions completely on, and for those of you that are going to get distracted by everything else, you're going to miss this, and then you're going to tell me I'm not sure, but that's okay. You can always come back and look at this later. When you get to the back, okay, remember, we're only going through 16. So the rest of that can get wiped here. Because that's something a little different going on after that than what we're doing now. And then for 13 through 16, you just find the next three terms because they're all arithmetic sequences. They all have a pattern that you can work with. Okay? So this, again, 1 through 16 is homework check number 10. So it'll be the one after this one that we're doing on Monday. Number 1 was the formula sheet we worked on yesterday. Yeah. Okay. Now, the other thing that goes with it is I wanted to practice some more with the formula stuff, speaking of those. So, let me get this one marked for you, and let's do a few of these. Now, on the solving formulas sheet, we are only going to do evens, which is nice. So we can get a big ol' X through the left side of the paper. You also can wipe out number 24, because that's, again, a little different from some of the stuff we've been doing. So on this sheet, evens only, but you even get to skip number 24. So,
On the bottom, we cross out like 19.
yes, everything on the left side of the sheet can be crossed out. So here's what we're going to do. We're going to use the calculator.
Right hand, what one?
Number 24. The left side of the sheet and number 24 are being skipped. So here's what we're going to do. It's asking us to find one of the variables, but they give us the information for the rest. So here's how this goes. They give me the formula. So A equals, they give me pi, and they give me the R. So basically, all I have to do is type this into the calculator once I substitute the values in, because they give them to me. And whatever comes out, so this would actually be an application of what we were doing yesterday. Now, is it always going to be quite that straightforward? No. For example, number 6, I'm not looking for A. I'm trying to find out pi. So here's how this works. I still am going to take the formula they give me, except now I know what A is. I don't know what pi is, even though I really do. And my radius squared. Now this time I got a little work to do. So I may have to do a little scratch work on the back of the paper or somewhere else, but I'm going to find a way to squeeze it in here. So I look at this and I say, okay, anybody know what 7 squared is? Anybody? What's 7 times 7? 49. Okay, so 154 equals 49 times pi. And I'm going to solve this equation just like I would an equation if that were x. So if this were 49x equals 154, what's my last step to undo that 49 and get it away from my pi? How do you divide. And then I just do that part on the calculator. So pi equals, let's see what 154 divided by 49 is. I have a feeling I know.
It's been to 28 years of college. Oh, Lord, that.
She said 28 years of college. I started college when I was 10 then. That'd be impressive.
A little exaggerated, actually.
Just a little exaggerated. That's okay.
That's the only.
Who are you talking to?
Chloe said, how do you know all this? I said, you've been to college.
Said I've been to college for 28 years. No, I know.
Exaggerated.
Just exaggerated a little.
9 years. That's pretty cool.
Probably from teaching it over and over again.
That too. Yeah, repetition always makes things easier after time. It's true. All right, let me find another one that's a little bit tricky so we can make sure we got this down here. Let's do, yep, that's it. Let's do 16. Move down a little here. Okay, find B when A, and again, I'm just plugging these numbers into the formula. One half. I don't know what B is, but I know what H is. So here's what I'm going to do here. Once I've plugged those in, this 1/2 and 7 are being multiplied on this side. So this would be and that's just from multiplying the 1/2 and the 7. And I only got one step left to get B. How do I undo timesing by 3.5? Divide. Perfect. Let's see what that is. 154 divided by 3.5. 44. And I've got my answer. So I'm just substituting in. And then to get you one in the bottom here too, which one of those 3 at the bottom you want to do with me? 20, 22, or 26?
All of them.
No, which one? 27? Oh.
20.
20. Okay. So we're trying to solve for y. So I want to get y by itself. Right now I'm adding mx to it. So what's the opposite of a positive mx? A negative or a minus. Okay.
What you want. Not equal to what you want. You might try to take them off.
So here, those that cancel. Now, my y is not quite alone yet, because there's a -1 that I'm multiplying by. To undo that, I'm going to divide by -1. What happens when you get a negative divided by a negative?
Turn into a positive.
Right. So this negative divided by negative becomes positive. Negative divided by negative becomes positive. and y's alone, and I'm done. So just, you're always undoing whatever that variable isn't going to be. And you just keep working on undoing the stuff away from it until everything's gone. Okay? So you got these last 20 minutes to kind of try some of these out. And again, if you get confused on something, try some. Come up, let's talk. But otherwise, work on those. Like I said, if you need to work on any of the assignments up on the board from homework check 9, because that's Monday, that'd probably be a good idea.
Wait, you have a good homework check 10.
Right, this is because, remember, I never will put something on the homework check for like the next class period. So it'll just be, and I have all the sheets up here if you need to see one for the homework check for Monday. But otherwise, we're just going to work on the rest of this with some work time. And yeah, that's about it.